Good day, significance viewers. I remain Mr. Simplicity, and today we are going to be looking at the topic differentiation from first principle. And this time around, we want to consider the trigonometry function of sine. So let's solve sine x using first principle. So first, we are given f of x equals to sine x. So we need to follow our procedures. Next step is to change x to x plus delta x. So that means I'm going to have f of x plus change in x equal to sine x plus delta x. Okay, so this will lead us to the next step that says take the difference between the two steps so far. F plus delta x minus f of x equal to sine x plus delta x minus sine x. There's a rule of trigonometry that says sine A plus sine B is equals to 2 sine A plus B over 2 cos A minus B over 2. This is a rule of trigonometry, and there are 4 of them. This is the first they normally give to us. The second one is if we have sine A minus sine B. And if you observe what we have on the board, that's the case we have sine A minus sine B. It says we have 2 cos A plus B over 2 sine A minus B over 2. So the other ones involve cos A plus cos B, cos A minus cos B, tan A plus tan B, tan A minus tan B. But since we are not dealing with trigonometry, we don't want to go into all that. All we need is this second case. So if I can remember the second case and recall it, I remember when we recall a trig identity, the intention is to replace the expression we had before we recall. So we are going to recall and replace these guys so that we can keep solving. So let's go back to the question. So I'm recalling that sine A minus sine B is equals to 2 cos A plus B over 2 sine A minus B over 2. So all I need to do is to compare the original part. A here is represented by x plus delta x here, sine A. B here is represented by x here, sine B. So sine A minus sine B, if we compare them, it means A is the first bracket, while B is x. So all I need to do is to replace it with this. We are replacing it with this expression, knowing that A is x plus dx and B is x. Okay, so let's substitute. So if we substitute, that will leave us with 2 cos x plus delta x plus x, which is A plus B, all over 2 sine x plus delta x minus x, which is A minus B, all over 2. At this point, let's simplify. If we simplify, we have 2 cos x plus x is 2x, collecting like 10, plus delta x all over 2 sine x minus x is 0, leaving us with delta x over 2. We are yet to get a free delta x. So remember that the next step now is to take limits if we have a free delta x. So remember that in limits, whenever we see the function sine, we normally convert it by multiplying by the whatever it's carrying and dividing by the same. So if we do that at this point, we are going to have 2 cos 2x plus delta x all over 2 times delta x over 2 sine delta x over 2 over delta x all over 2. In this case, I've succeeded in making this a special limit, and I've brought in a free delta x. From here, 2 can take out this 2. So let's see what is remaining. So now we're going to have cos 2x plus delta x over 2 times delta x sine delta x over 2 over delta x over 2. So let's move to the next step. The next step is to divide both sides by delta x. If I do that, I'm going to have f of x plus delta x minus f of x all over delta x to be equal to everything here, cos 2x plus dx over 2 dot dx sine dx over 2 all over dx over 2 all divided by dx. So remember, this stage is to cancel out the free delta x. So the free delta x is gone. Now what I have left is cos 2x plus delta x over 2 times sine delta x over 2 all over delta x over 2. Final stage is to take limits as delta x tends to 0. If I do that, limit as delta x tends to 0, f of x plus delta x, f of x all over delta x is now equal to, anywhere I see delta x now is 0, and the special limit goes to 1. So this will now be cos 2x plus 0 over 2 times 1, leaving us with cos 2x over 2. 2 can cancel out. Finally, we have cos x. So therefore, our f prime of x is cos x. So that's the solution to this problem. So this is another example on trigonometry. We're looking at the trigonometric function of cos x. So if we follow the steps we gave in the first video for first principle, we are going to replace x with change in x on both sides. So I have f of x plus change in x equals to cos x plus change in x. Then the next step is to take the difference, the second minus the first. So this will give me f of x plus change in x minus f of x equals to cos x plus change in x minus cos x. So when we looked at sine x, I reminded us of the addition formulas for sine A plus sine B and sine A minus sine B. And we used the minus because it was a difference. In this case, we were going to look at the other two addition formulas, which is cos A plus cos B and cos A minus cos B. Cos A plus cos B says this is 2 cos A plus B over 2 cos A minus B over 2. While cos A minus cos B says we have minus 2 sine A plus B over 2 sine A minus B over 2. So these are the two other addition formulas that we need to know. And in this case, we are dealing with minus. So we are going to be using the second one that has to do with minus. So let's go back to the question. So to move on with the question, we are now going to recall that cos A minus cos B is equals to minus 2 sine A plus B, 2 sine A plus B over 2 sine A minus B over 2. So remember, recall to replace. So this will replace this. My a will be x plus change in x, while my b will be just x. So if we take that, we are now going to have f of x plus change in x minus f of x to be minus 2 sine x plus change in x plus x all over 2 sine x plus change in x minus x all over 2. If we simplify this further, we have minus 2 sine x plus x is 2x plus change in x over 2 sine x minus x is 0. So we have delta x over 2. Just exactly what we did when we were solving sine. We made sine delta x over 2 a special limit. Okay, drawing this knowledge from where we treated special limits. Anytime we see sine, whatever is carrying can multiply and divide it. So if we do that, we're going to have minus 2 sine 2x plus change in x all over 2 times delta x over 2 sine delta x over 2 all over delta x over 2. So from here now, 2 can cancel these 2, leaving us with minus sine 2x plus change in x over 2 times delta x sine change in x over 2 all over delta x over 2. So this is a special limit now, and this is a free delta x. So I can move to the next step. It says we should divide both sides by delta x, which means I'm going to have f of x plus delta x minus f of x all over delta x equal to everything we have here, which is minus sine 2x plus delta x over 2 times delta x sine delta x over 2 over delta x over 2 all over delta x. So what you observe is that delta x is gone, leaving us with just minus sine 2x plus delta x over 2 times sine delta x over 2 over delta x over 2. So we cancel out the free delta x, so we can take limits now. So this will be limit as delta x tends to 0, f of x plus change in x minus f of x all over change in x will now be equal to, anywhere I see delta x here, I have 0, and this is 1. So this minus sine 2x plus 0 over 2 times 1. So now I have minus sine 2x, because 2x plus 0 is 2x over 2. So these two cancel out, we have just x, that's minus sine x. So therefore we can say f prime of x is minus sine x.